Hello, my dear students. Welcome to the IMS GATE. Now, let's cut foundation organization. I would say this would be last session. Most of the important topic word. So please go and watch the list of like that. Okay. So in this session, I would like to discuss on the DMA important topic. I will understand that how DME will work. The let's continue. DMA. What is DMA? Direct memory access. Now, what is like no? What is the importance of, as we know, I what if memory? Here is a memory. Here is high device. All three common. All this is what this. Understand the importance of the topic. The talk. See the high devices how they connected interface old computer directly when you use programmed IO. Now you understand when the DMA has been is from this IO device, from this IO device. So what like what way the data transfer in IO? What mode? What are the modes for transferring? There are three protocols we have. Programmed IO, programmed IO, or program interrupt, interrupt IO, interrupt IO. Third one is that. So let us briefly answer. There are three ways like data transfer happens. IO device. Processor will intervene on for transfer data bit is another programmed IO. Now see, so in case of programmed IO, in case of interview for a transfer IO device. So when you go and discuss on the DMA where processor will call for a data, we are bypassing the CPU for a controller. Now DMA control special hardware memory IO without involvement of. So why sir? Why it is the operating system point we want to virtual understand clearly. Most of you virtual memory. If you want to implement the virtual memory concept, what this is, runtime only data from disk to. Now that is going to be heavy burden to the, hence separate component we can use for bulk transfer bit from disk to disk, runtime only. Hence really needed for implement virtual memory. Here my point, this was an object. It is kind of like special processor, you understand. This is a CPU, general processor, general CPU, right? General CPU. So now this is special processor, DMA. The purpose is to not to run any kind of instruction. The purpose only simply transfer the data between and IO devices. That need to be. Now let's see the separately on few points I mentioned. The few points you can observe. What I said, DM is a method that allow IO device to or receive memory. So all the students, like I'll be taking back. Hello students, just can you confirm me, are you able to get the audio properly? Hello my dear students, is it clear now? Can you please confirm me? Okay, so now let's continue the part of the DMA. So what I was telling, like, we'll understand the framework of the DMA controller. The few points I mentioned here, the purpose of the DMA is to bypass the processor, to speed up the memory operation. Means you have to, whenever you want to transfer the bulk amount of data from the device to memory and memory to device, so we can use a DMA controller. So during this DMA transfer, please understand what I was telling. So during DMA transfer, the CPU is sitting idle and has no control of the memory bus. So means in the single bus architecture, the system bus is shared between the processor and the DMA controller as a master slave. Meaning whenever a DMA is taking the control over on the system bus, so now the CPU has to sit in ideal case here. Or you understand, some cases processor can also work parallelly to the DMA controller, which is not required the system bus. When the CPU is going to be ideal state, when during DMA transfer, whenever a CPU is required the system bus to use a fetch instruction or store instruction. Whenever a CPU does not require any system bus to perform the operation, it can be parallel to continue with what? The DMA controller. Now based on the system bus is returned to the processor, the DMA can work in 3 modes. One is the burst mode, second is cycle stealing mode, and third one is a block transfer mode. So I hope the points is clear. Third one I'll write here. The first mode is what? Burst mode. Based on the system bus is returned to the processor, means when the system bus is relinquished by the DMA controller to the processor, the DMA can be work on 3 modes. What are 3 modes? One is burst mode, second is cycle stealing mode, third one is a block transfer mode. Third one is a block transfer mode. Block transfer mode. So now let us understand. How the framework of the DMA controller will happen. Then we can see the one by one, like bus mode, the cycle stealing mode, block transfer mode can be understand. So I hope the point is clear. This I'm just repeating the statement. Very simple. Whenever we want to transfer bulk amount of data from the disk to memory or memory to disk, so the DMA controller will involve for transferring the data. So in this moment CPU will not involve. The reason I told you, what was the reason to introduce the DMA controller? Whenever operating system point of view, if you see, if I want to implement the virtual memory concept, hardware support is highly needed. The hardware support is nothing but existence of the DMA controller is required, so that no memory operation can be speed up. Memory operation can be speed up. Understand? So understand here. So now here is a CPU, right? Here is a CPU. Okay, here is a CPU. Here is CPU. Here is a memory. Here is a memory. Observe. Here is a memory. Now, so let's take this IO device is there. IO device is there. IO device. Understand here. Now, so generally processor used to intervene for transferring the data between device and memory, which the initial 2 methods like programmed IO and interrupt driven IO. So now processor used to fetch some memory instructions and reading the data from IO device and transferring to here. So here and then, so it used to happen by the processor only. Now this is like I am introducing what DMA controller. Here is a DMA. Okay, here is a DMA. Now when a DMA is involved, so now data transmission between the memory and device will happen through DMA controller only, not by the processor. So that is understanding. So we can do right now. So look at the small sample diagram I have drawn. So where the DMA controller connected and device and memory and processor is there. Now let's understand the step by steps the framework of the DMA controller. Look at the picture. Observe now. Now see. So processor naturally used to do the transmission between memory to disk, but we are placing the DMA controller. Now how process goes, observe clearly. So this is system bus mode. So this is system bus here. The system bus containing 3 things which we know. The system is containing 3 things. What are 3 things? Address bus, control bus and data bus. Address bus will carry the address signals or address line to particular device or memory to address the location where to read or write the information. So data bus will carry the what data. So a control bus will signal the what kind of operation we are carried out. So either read operation or write operation given by the what the right control signals. Control signals are the separately mentioned, read control signal, write control signal mentioned, right. So now how that goes, I'll be taking the situation, so including the operating system view. Observe clearly, all of you now. Suppose example, I am running the virtual memory based operating system here. So virtual memory based operating system, if you observe, so complete program is not required to load into main memory. Some part you can load in main memory, remaining you can keep inside secondary memory, you can start execution. Let's say that environment, demand paging environment, I am running the program. When the program is given some reference to fetch instruction from the main memory, so that page fault is occurred. So I hope you know the meaning of the page fault. When the processor trying to fetch a page or a data from the memory, but the page is not available, which is not yet brought into main memory, it is maybe present in secondary memory only. So that indication page fault. The moment page fault occur, interruption goes to the operating system. Operating system will recognize what kind of interrupt is the page fault, is exception. Now we need to bring a page from secondary memory to main memory. So now, so operating system means what? Virtual memory manager will inform to the device manager will inform to the device controller inform to the device drivers. It is a software. So device drivers signals to the device saying that read a data or into like transfer data from disk to memory. Now device is putting a request to the DMA controller. See step number 1. So the step number 1, device putting a request to DMA controller saying that yes, data transmission need to be due. Now the DMA has to transfer the data from where? Disk to memory. So memory where to transfer? We don't know. How much data need to be transferred? We don't know, right? Yes or no? Now the basic information required for the DMA controller to initiate the IO transfer here. Now, so now second step please observe. Now, bus request signal is there. No, step number 2, bus request. DMA controller putting a request to the processor saying that I need a system bus. I need a system bus to transfer, because system bus is common between the memory and the peripheral devices. I need a system bus controller so that I can initiate the IO transfer, putting a request to the CPU. Now processor will grant. Processor will be busy with a normal execution, right? So it may be fetching or decoding or executing, whatever steps it might be doing. Now in end of the state, current state, it will recognize the DMA request. Processor will recognize the DMA request and release the system bus by initializing the information, because DMA controller not having any information how much data need to be transferred, I should transfer or read, and way to transfer. So this information required. So now processor will give this basic information. The basic information we call initialization of the DMA. Whenever any request comes from the DMA controller, processor not end of the instruction cycle, end of the current state will recognize the DMA controller. So DMA request, please understand, DMA request is the high priority over other interrupts. Suppose if you take interrupts or any non-maskable interrupts, if you see, among the DMA request is high priority. So now this will be acknowledged or recognized by end of the current state of the processor. So now processor will recognize and giving the basic information saying that yes, you have to read the data from so and so location. Initialize the address register. You see, initialize the address register. Initialize the data register, data count register, saying that how much data need to read it, and is giving the control signal of what? Read or write control signal. So this basic information given by the processor to what? DMA controller. That is step number 3. Understand step number 3. Now step number 4, please observe step number 4. So now that's what step number 3 comes. Bus grant, so this signal get activated by giving this information. Step number 4. The step number 5, observe the step number 5. So DMA giving the acknowledgement to the disk saying that yes, just enable the data line. Just enable the data line so that I can transfer. So data line going to be enabled. Step number 6, you understand, 6, and start transferring the data. Start transferring the data from disk to memory or memory to disk here. Now sir, how much data will, whenever DMA controller takes the control of the system bus, how long it will hold system bus? How long it will load? Yes, that's what based on the releasing the system bus. Based on at what time it releasing or how after what some time it releasing system bus, based on that only So DMA controller said it works in 3 modes. What are 3 modes? Burst mode, cycle stealing mode, and block mode. So for example, I want to transfer one file size 4 KB data I want to transfer. Once I get the system bus, the now data transfer initiated till its completion, all 4 KB data transferred. So now fully utilized. So DMA controller using the system bus until or holding the system until its full data transmission is over. The 4 KB, this is one type of mode. Other type of mode we can say, instead of holding the complete system bus till its completion, so I can release system bus after transfer some amount of data. This is another mode. Like this we have 3 modes are there. So now let's discuss on the 3 modes here. What are 3 modes I said you? What are the 3 modes? Burst mode, burst mode. So burst mode, okay. So you can write burst mode nothing but please understand. So system bus, so system bus is released by the DMA after entire data transmission, after entire data transmission. I hope you understand this line. The full, suppose the device is saying that I need to transfer some 4 KB data, 5 KB data, 10 KB data. So at a time. So now once a DMA controller receives the system bus from the processor and basic information, so then it will transfer entire data, then only it will release the system bus to the processor. Now, so during this burst mode, you understand, processor can do its parallelly what works, sir? So processor can continue the work which is not required any system bus to be used. Let's take example. Arithmetic logical operations. Generally load store instruction required to use a system bus for fetching or storing the instruction or data from memory. Correct or not? But arithmetic logical instruction, if it is carried out in a register level, so does not require any system bus. Once load operation is over, addition or subtraction operation can be carried out on register level. During this work time, the processor can be busy. Now whenever a process required to use a system bus for fetching another instruction or store the results into memory, the system is required, right? Now it can going to be blocked. So now I can say, so in this mode, so longer period of time, the system bus is held by the DMA controller, hence processor waiting time is more. So I can say processor CPU waiting time. So you can mark, all of you, all my dear students, just mark the important line here. The CPU waiting time is more. Which case, sir? Which case? So under burst mode. So under burst mode. Now the second mode saying that the second mode. What is second mode? The second mode is a cycle stealing mode. Cycle stealing mode. Understand the points, understand the point. Understand the point, because the problem solving it will be easy. For problem solving it will be easy. For problem solving it will be easy. Understand. So now in the burst mode what happened? So data bus, system bus is held by the DMA controller full transmission time only, right? Now in this case what happens? After every word transfer, I am writing after every word transferred, the system bus is written. The system bus. So system bus is returned to the CPU. Okay. Meaning example, I want to transfer 100 words assumption. 100 words need to be transferred from disk to memory. Okay. 100 words need to be transferred disk to memory. Now, one word you transfer, release the system bus. Then inquire after every instruction cycle. Inquire after every instruction cycle. Again, if you get a system bus, then transfer another word, release it. Again transfer another word, release it. So every one word transmission is over, the system bus is relinquished to the processor. In this case, DMA controller waiting time is more or not? Yes or no? So in this case, DMA. So DMA waiting time. So DMA waiting time is more. So DMA waiting time is more. This is also important line you can understand now. So to resolve these two problems, what I can do? So combination of these two method. What is combination of these two method? Cycle stealing mode, bus mode. The third one is what? The third one is what? Third one is what? The block transfer mode. Block transfer. What is the block transfer, sir? So instead of one word transfer or instead of full transfer, so full transfer, now block by block we can transfer. Block transfer mode. Now in this code, in this case what? In this case what? System bus is returned. System bus is returned to the CPU after every block transfer. Every block transfer. In this case, so block size is, what is block size in terms of words? Suppose let's take example 256 words. Example I am giving, or 128 words, or it may be 1024 words, like this, you know. So I'm like having more than words, block size more than words, 64 words, 128 words, 256, even 1024, 256, like this. Okay. Now instead of releasing the system bus every word transfer, or instead of releasing the system after every completion of the data transmission, in middle after every block transfer you can release, what happens? CPU time is waiting time also less, and DMA waiting time also will be managed. So that is the mode of what? It's a block transfer mode. I hope you understand three things. One is bus mode, cycle stealing mode, and the block transfer mode. So this is a basic information about the DMA controller. I hope you understand. So now look at the few other observation we can see. So I hope this statements are clear, right? The steps is clear. I'll just repeat the steps. You see, what are the steps? Simply the step number 1, DMA putting a request to DMA controller, saying that so and so data need to be transferred or received. Second step is going to put a request to the processor saying that I need a system bus by the DMA controller. That's we got, that will go in terms of bus request. So this bus request signal also known to be hold signal. So we call DMA controller signals, we called HOLD. Hold signal is a bus request. So when you put a bus request, the processor is recognize the the DMA request and release the system bus by initializing the basic information. So bus granted. So bus granted. So bus grant signal we called HLTA, means acknowledgement given. Who is given acknowledgement? Processor given acknowledgement. This step number what? 1, 2, 3. Third step. Fourth step, give acknowledgement to the device saying that enable the data line. Fifth step or sixth step, transmission will takes place here. So this transmission will keep on happens until, so based on the what mode of the DMA is working. So now, so DMA, so working in 3 modes that I discussed. Now one more thing need to be understand here. So what one more thing need to be understand here. So DMA initialization, okay. So DMA initialization steps. DMA initialization. So initialization steps. DMA initialization steps. Observe all of you. So whenever process get the request from the DMA, so now it will grant the bus, right? HLDA signal, acknowledgement giving to DMA by instance. Step number 1. The step number 1, so now it will initialize the address register. It initialize the address register. Address register contain the starting address of the memory location where you want to write or read operation is carried out. You want to read from that location onwards, or you want to write from that location onwards. Read or write operations which we are going to carry out, right? So from what location, from what address onwards this operation need to be carried out. So you have to initialize the address register. The second one is, so second one is the data count register. Data count register. You have to initialize what? Data count register. So what is the purpose of data count register, sir? This is saying that how much data need to be transferred. How much data? So how much data need to be transferred? So number of how many words? this initialization, the step example. So example you see, example is a, so data count register is suppose initialized to 3-bit. Data count register is initialized to 3-bit. So now 3-bit combination, how much data you can count? So 0 to 7, right? 0 to 7 nothing but 8 words need to be transferred. 8 words need to be transferred here. Suppose this initialized to 7 bits. If this is initialized to 7 bits, tell me how much data need to be transferred here. So 128, yes, 0 to 127, 128 words. So based on the data count register. So step number 3, the step number 3, observe. Step number 3, the first address given, data given, so then control. What is control? Control signal, control command, control signal, control, either read operation or write operation need to be carried out. So these are the basic information as to give by the processor to the DMA controller, so that DMA can initiate the IO transfer based on these things. I hope this point is clear. Yes, the steps is clear. So now I'll be taking as a question number 1. You see the question number 1. Okay. So now the question number just it is not exactly the from the gate point of view, but I want to see the what are the steps, what are the process, what is the framework of the DMA controller will do. So during transmission, so just we can observe from this question. It is necessary to transfer 256 words from magnetic disk to memory, starting address from 2030. The transfer is by means of DMA controller. How much data need to be transferred? 256 words. Give the initial value that CPU must transfer to the DMA controller. Initialization process they are asking. And second, give the step-by-step account of an action taken during the input of the first 2 words. So when you are transferring the first 2 words word by word is nothing but cycle stealing mode. What will you write? Give a steps for this they are asking, so that with this question we can able to understand the process of the DMA controller which takes place, so that we can observe. Please note this information so that we can work out. Now see, so now we need initializer. So now look at the step number, first question 1. Okay, so initialization steps, right? Initialization. So initialization steps. Use the initialization step. What is step number 1? Address register, right? AR register. Okay. What is the address register they said? So from memory 2030 onwards, this address register. Okay. Step number 2. What is step number 2? So data count register. How much data need to be transferred, sir? So we need to write 256 words. Okay. So now see, we are transferring. Where are transferring? They said 256 words from magnetic disk to memory. You have to transfer. So transfer nothing but what? The write operation. We are writing into what? Memory only, right? Write operation from disk to memory. Write operation. So this initialization step process. Okay, this is clear, right? So we know the starting address, we know how much data need to be transferred, then what operation need to be performed. So that information is given. The second question, what is second? Step-by-step actions. So step-by-step actions taken place during this first 2-word transfer. So just tell me. So what I said you, steps, tell me the steps. Let me write here. Let me write steps. For second question step, what is step number 1? So what is the step number 1? What is step number 1? Okay, generally, so disk, no, disk, okay. Disk put a request to what? DMA, right? DMA controller, request this line is. Second one, okay. So whenever you receive the DMA request from the device, it is also putting a request to CPU. Which signal? Which signal? Hold signal. HOLD, old signal, okay, putting a request, bus request. Step number 3. So CPU recognize and bus grant. It will bus grant to DMA controller. Bus grant. What is the bus grant? HLD acknowledgement gives. Okay. By initializing. What is initialization steps I said you? So in this initialization steps what? Address register should be 2030, right? Data count register should be 256, and which signal? Control signal is right signal, like right signal. So this initialization steps by the one. Step number 4. What is step number 4? The step number 4, DMA. So DMA giving the acknowledgement to whom? Acknowledgement to on disk, saying that enable the data line. Step number 5. What is the step number 5? So transmission. So data transfer. So data transfer takes place. So takes place between what? Device and memory. How it will go, sir? How it will go? Okay. First one word you have to transfer. Okay. In that, I'm breaking the fifth step. I'm breaking the fifth step, ma'am. I'm breaking the fifth step. Observe. Breaking the fifth step. Step number 5 only, right? So breaking the first one. Okay. Step A. Transfer a word. Okay. Transfer a word at specified location. Specified location. What is location? What location? At 2030 in memory. Transferred. In the memory location 230, transfer word. We transferred the step number 2. See, B, step number B. Once you transfer, but how much data need to be transferred? 256 words you need to transfer, right? Yes or no? So you have to increment. Please observe. Location. Next word you have to transfer next location, right? Increment the word address register. So now when you increment your address register becomes what? 2031, right? Step number 3, decrement what? So decrement what? Decrement the data count register. Already one word you transferred. Now 255 it becomes 256 to 255 it will become, right? So decrement what? This register. Now signal is given. What signal? Right signal. Control signal is what? Right signal. Okay. Right only. We are writing only, right? So this is not required. The steps can be repeat. Okay. Now see. So now you have to transfer one word. I transferred. Increment address register. Decrement the data count register. Right. So now see the steps. Steps A comma B comma C has to repeat, right? Repeat. So this has to repeat until tell me until data count register becomes 0. Yes or no? What is 2 steps they asked, but I am going to all steps. So second step, if I want to write it what? You have to transfer one more word and increment the address register. How much address is going to happen? 2032. And decrement the data count register means 20254 it will become. So every time increment next location, decrement the count. You continue these steps. Which step? Step number 5. So step number 5 only, right? Step number 5, ABC. Repeat these steps until data count register becomes 0. Once this becomes 0, what would the 6th step? The 6th step is data transmission over, right? When the data transmission is over, you have to release the system bus, right? Now I understand. So now, DMA. So now steps number 4, DMA. Okay, interrupts to whom? Interrupts to whom? So CPU and release the system bus. SP means system bus. So now see, go and see the diagram. Go and see the diagram here. You see the diagram. Okay. You see one line I mentioned here. Interrupt. Here is interrupt. Interrupt from DMA to whom? CPU. When interrupt signal is encountered, whenever data transmission is over, you have to interrupt, release the system bus. This can be happen for under 3 modes. Like whatever mode you are using, suppose you are working with a cycle stealing mode. You transfer one word, release, interrupt the CPU, release the system bus. If you are running with a block transfer, you transfer one block, release the system bus. If you are running with a burst mode, release entire data, transfer entire data, release the system bus. So that need to understand here. Okay. Clear? This is clear? So now the 6th step, I am releasing the system bus. So now suppose you are working with a cycle stealing mode, again you have to inquire. If the burst mode not required, whenever again device is getting a request from the device to the DMA controller, then again you put a request to the CPU for getting the information. This is the process goes. I hope the steps which I want to discuss for this question is clear, right? So is it clear, all of you? Chalo, we'll move another question. So before solving this question, also some observations, some important note points, ma'am. Observe all of it. This I am marking as a note point, which is very important points to solve the questions on DMA controller. You mark it, everybody. This is very important, this note points. Okay, note number 1. Note number 1. Okay. Percentage of the time. Percentage of the time. See what happens, I'll tell you. Why I'm marking this one. If I take burst mode, what happens? Most of the time CPU is waiting or not. Yes or no? Think yourself and answer me. In a burst mode, initialization process time only CPU will be busy because you have to initialize the DMA. Once you release the system bus or DMA controller, now DMA controller will take complete control on the system bus, it will transfer until its completion. So most of the time CPU is ideal, right? Most of the time system bus is not available to the processor. So processor sitting idle mode. In case of cycle stealing mode, what happens? So processor will initiate the system, like initialize the DMA. Now when you initialize when the DMA will read the data from the disk and transfer. So now transfer one word, release the system bus. Again you inquire. During transfer time only, please, during transfer time only, the CPU sitting idle. Once one word you transfer, release the system bus, nothing but the system bus again used by the CPU only, right? So these two important point I can write. So what percentage of the time, the processor, okay, percentage of the time, the processor means CPU is blocked. Percentage of the time CPU is blocked in cycle stealing mode. Cycle stealing mode is given by I am marking Tx by, so Tx plus Ty into 100%. Okay, what this expression is giving? What percentage of the time CPU get blocked in cycle stealing mode because of the DMA transfer? So that I want to know. So now what would be the Tx here? What is the Tx here? Tx is, observe, Tx is data transfer time. Data transfer time means whenever word is available, when the word or data is available from the disk, just you have to place in data bus and transfer. During this transfer time, the system bus busy with the DMA controller or not. So when the system bus is busy, processor suppose that moment only system bus required, so it's not able to utilize. So CPU is what sitting ideal. So that I want to know. How much percentage CPU is getting blocked due to DMA transfer in case of cycle stealing mode. Now what would be the Ty? So Ty is a data preparation time. So what is the data preparation time, sir? Because I have to read the data from device or not? Data preparation time. We have to read the data from device or not? We have to read the data. To read the data from the device and transfer. During reading of a data from the device, so system bus can be used. System bus can be used by the processor. So processor is not sitting idle. During transfer time when sitting ideal, preparation time it can be used. Please understand this point. Okay. Because one word transfer only, one word transferred, release system bus. It can use it. Next word to preparation. Preparation time depends on the amount of data you are reading, how many words you are reading, one word size length, and the speed of the device. What data transfer rate of the device, understand, speed of the device. What rate data transfer can happen from the device, based on that preparation time will vary. This is the parameters you have to substitute. You will get the amount of time, percentage of the time CPU sitting idle in a cycle stealing mode. This one observation. The second observation is, under burst mode. So I am writing percentage of the time, the processor is busy or active, or percentage of the time processor contribution, processor is contributing is given by. So now they can use the terms busy or active, processor is active, or it is some contributing to the DMA controller is given by, I am marking again, so Tx by, so Tx plus Ty into 100%. So this is specially in the burst mode. This is specially in burst mode. Burst mode meaning, what is burst mode? What is the meaning burst mode? Burst mode means once you get the system bus, so till completion of the entire data, system bus is not relinquished by the DMA controller. In this case, the waiting time of the process is more. When the process is active, initial time, initialization time only processor is active or not, because it's giving address bus, all the things is busy. Processor is busy for initializing the DMA controller. Once initialize and release the system bus, now it will now control over the system, but it is going to be high impedance state. DMA going to be high impedance state. Now what would be the Tx here? What is a Tx? So Tx is, understand now here, so question is reverse. Here we are not asking how much percent blocked here in burst mode. Most of the burst mode is blocked only. But we are asking in reversely how much percentage time the CPU is active for initialization, active in case of burst mode, or busy contributing some work to the DMA controller I am asking. So now this is going to be like initialization. So initialization. So initialization of the DMA and termination of the DMA process. DMA, termination of the DMA. The amount of time taken to initialize the DMA or termination is in that what active CPU is active. After that, CPU going to be block only. So now Ty is going to be, so now fully transfer time, data transfer time. Data transfer time includes here, so includes here preparation time also. Data transfer time means preparation time also include, because most of the continuous we are reading transfer happens on. See one example I have given, 256 words I have to transfer. You transfer, increment address register, decrement decrement the data count register, transfer. You have to repeat these steps continuously until the data count register becomes 0. The data count register becomes 0. This is what burst mode. So now this is a consideration. So this important expressions, important these formulas need to be understand. This I am going to use and in problem solving now. In problem solving, look at the question number. Next question. Question number 2. If 1 Mbps, they said 1 Mbps is operated in cycle stealing mode such that whenever a 64-bit word is available, it will be transferred into the memory in 1 microsecond. 1 microsecond. What is the percentage of the time CPU get blocked due to DMA transfer? So are they mention any which mode of the DMA is working? Are they mention which mode of the DMA is working? They said the device rate, the speed of the device is 1 Mbps, meaning 1 MB data can be transferred 1 second. That is the rate of the data transfer rate of the device here. Is working, they said, clearly in cycle stealing mode, they said, such that whenever one word is ready, it will be transferred to memory in 1 microsecond. During this transfer, how much percentage of the time the CPU is getting blocked is dash. They are asking. That's only we understand, right? So we need to find a percentage of the time. Percentage of the time the CPU is blocked in case of cycle stealing mode by given by Tx by Tx plus Ty, right? What is the Tx, sir? Tx is transfer time. What is transfer time? Are they given transfer time? Yes, they said 1 microsecond. 1 microsecond they said. Sorry, 1 microsecond. They said 1 microsecond. So now we need to find out the Ty. What is the Ty, sir? Preparation time of the word. As I say, same thing given, right? Preparation time only. Word data need to prepare from the device, right? Data need to be prepared from the device. Understand? Here is a memory. So this is a memory. This is a memory. Now here is a device. Okay, this is the device. This is the disk. What is the rate of the disk is 1 Mbps. Okay. Now we are transferring the data from disk to memory by using what? DMA controller. DMA. Here is a DMA. Okay. Now see. So DMA taking transfer time, how much? Tx value, how much it is taking? They said 1 microsecond. Whenever one word is available, one word What is the one word value? One word equal to 64 bit. If 64 bit data is available, it will transfer in 1 microsecond only. But need to be find out which value. So Ty need to find out. What is the Ty, sir? Data preparation time. So how to get the preparation time? Observe clearly, all of you. Preparation nothing but you have to read the data from device only, right? Understand the basic information here. Preparation means we have to read the data from device. We have to read the data from device here. Clear? Read the data from device. So how to read data? I said reading of data depends on how much data you are reading and depends speed of the device also. How much data you are reading? I want to read 64 bit data. What is the rate of the device? 1 Mbps. It is saying that, sir, 1 MB, 1 megabyte data I can read in 1 second. That is the capacity of the device here. But I don't want to read 1 MB data. I want to read 64 bit. 64 bit nothing but 8 bytes only. Is it not 8 byte? How much time you will take? You can put a question, right? What is the rate of the device is? 1 MB per second. But I don't want 1 MB. I need only 8 MB. Sorry, 8 bytes only, right? 64 bit nothing but 8 bytes only, right? 8 bytes. How much time will take? So that is only Ty. So now Ty equal to, I will use here. So Ty. So now Ty equal to, okay, Ty equal to, what should I write it? So this 8 bytes by 1 MB. 8 bytes by 1 MB. So byte cancel, right? 8, okay. 8 by 1 M, nothing but 10 power of 6 only. So 8 into 10 power of minus 6, here was seconds were there, right? So now say 8 microseconds. It is 8 microsecond, right? Now percentage of the time CPU is blocked in cycle stealing mode equal to Tx value. What is Tx value? 1 microsecond divided by 1 plus 8. So this giving 1 by 9. So what is 1 by 9 value? So what is 1 by 9 into 100% is only, right? Yes or no? So what is 1 by 9 value? Yes. So this is into 100 you can multiply. It is going to be 11.11 percentage. So this is the percentage of the time CPU is blocked. So this way you can answer it. That's it. This question is, the meaning is same only. This means this. So they are asking what is the percentage of the time CPU get blocked due to DMA transfer is 11% approximately, can tell. Look at another question. Okay. Look at another question. A processor using 600 megahertz clocks, it consumes 1600 clocks for initialization, 800 clocks for the termination. A device of 100 Mbps is connected. It is required to transfer a file of 400 KB. What is the percentage of the time processor contribution in this data transfer? So the word active, the word busy, the word contribution is given. You would understand they are talking on burst mode here. They will ask how much percentage CPU is active here they are asking. So second formula I need to apply. What is second formula I said? Tx by Tx plus Ty. What is the Tx? Initialization termination time. Ty your data transfer time. How much the data they are transfer? 400 KB, sir. Sir, what is this line, sir? 600 initialization and 800. What is this one? Very simple. So processor requires some time to initialize the DMA controller. As you know, I mentioned address register you have to give, data count register you have to give, you have to say which operation need to be performed, right? This is initialization process. Termination process meaning what? So taking the control of the system bus back to processor, right? Yes or no? So this is taking some time. So processor clock rate, what is the clock rate of the processor? Clock period or clock rate of the processor of 600 megahertz. So 600 megahertz they said. Now say 1600 clocks and 800 clocks required for initialization process only. So now let us understand how we can solve here. This is a memory, okay? This is a memory, okay? Where I want to transfer data. From where? Device. This is a disk. What are the disk rates? Disk rate is rate of disk. Disk rate is what? What they said here? Somewhere 100 Mbps is connected. This is 100 Mbps. So 100 bytes per second is transferring. So we have to transfer from disk to memory. By using what? By using what? DMA. So by using DMA controller. Correct. This is how much data need to transfer. So we have to transfer the file size. File size almost 400 KB file. We have to transfer 400 KB file, not 1 byte. It is a burst mode only. So now, so what I do? TX. What is the TX here? TX preparation time, sir. Sorry. Initialization. Initialization. How many clocks taking? 1600 clocks for initialization, 800 clocks for termination. Now total 2400 clocks is taking. Clocks for this process. This is the preparation time. Now transfer time need to find out. But time, in terms of time I need. But we got in terms of clocks we got. So what I can do? Clocks replaced by the time. Can't we do it? So what we can do? This is 2400 clocks. So we need to find a clock time. Clock time is what? Clock time, please. Clock time is reciprocal to clock period. But please understand this one. Very important point you can understand. Clock time, cycle time of the clock. Cycle time, one clock is reciprocal to clock period. Or if you know cycle time, we can get the clock period. If you know clock period, we can get the cycle time. So they said not clock period. What is the clock period? 600 megahertz. Now, so 1 by 600 megahertz. 1 by 600 megahertz. Yes or no? 1 by 600 megahertz. Then this value will be, so what is the TX value will be now? TX equal to, so this value how much? So this will cancel, right? 0 cancel. This 4 only, right? So we'll get 4 by 1 megahertz. So 1 mega nothing but 10 power of 6 hertz. Can I write it? Hertz, can I write it or not? Now send upside 4 into 10 power of minus 6. So the 1 by hertz becomes the second. So this becomes a 4 microseconds it will become. Is it not 4 microseconds only or not? 0 cancel, 6 was at 24 only. 4 microseconds we got. Right, TX value. Now need to find out the TY. What I say TY? Data transfer times. 100 Mbps, right? 100 MB, megabytes per second is the device rate. But I don't want transfer 100 MB. How much data need to transfer? 400 KB. So how much it will take? Now TY equal to, so 400 KB. So 400 KB file into 1 second divided by 100 MB file. 100 MB file. Byte cancel. 0 cancel. This is going to be 1M. So now 1K means what? So 1K can I write 1000? So now 4000. 1 by M. M can write 10 power of 6. 10 power of 6 send upside. 10 power of minus 6. Here unit second is there. 10 power of minus 6 second it becomes 1 microsecond. So this becomes 4000 microseconds. I hope you understand. So I hope you understand this point. 400 microseconds. 400 microseconds. Now see, the percentage of the time CPU is active or contributing this process will be, so this 4 microseconds divided by 404 microseconds, right? 4000 plus 4. So this giving what? 1 by 1001 into 100 percentage. So this gives how much percent it will give? How much percent it will give? 4 divided by 4004. This giving, so 9 point, is it clear? Into 100 into 100, 0 point, yes. So 0.09, this is 0.09 percentage is active. Remaining time is blocked only. So remaining time is blocked or not? Yes. So what is the difference in this question? Difference in this question is that burst mode here. So the big file need to be transferred. Initialization, termination time need to be taken in terms of clock given, clock period already given, that you take the time, and transfer time is nothing but preparation plus transfer. That depends on my device capacity. The device kept at 100 Mbps per second. I need to transfer this much time. How much time it will take him? So that need to be considered. Clear? So chalo another question. So this fourth question you can solve. Okay, you can solve. Hard disk with a transfer rate of the 10 Mbps per second. 10 Mbps per second is constantly transferring data to memory by using DMA. the processor runs at 600 megahertz, takes 300 and 900 clock cycle to initiate and complete the DMA transfer, so respectively. If the size of the transfer is 20 kilobytes, what is the percentage of the process time consumed for the transfer the operation they are asking? Again, it is same question only, ma. Data is different. So in this previous problem, 100 Mbps is connected, here 10 Mbps. There is 600 megahertz clock rate only. They are taking 600 plus 800, here 300 plus 900 is taken. 400 KB file need to be transferred. Here how much file need to be transferred? 20 KB file. So you believe me, same answer you will get. You try to this question, your answer is 0.09% only you will get it. Just take this question as a homework, verify you will get this answer. Verify you will get this answer. Verify you will get this answer. Fine, you try it out. We'll move to another question. Look at this question. This question was asked in GATE 2016, set number 1 for 2 marks. This was question number 4 marks, so this is question number 5. Question number 5. This question was asked GATE 2016 for 2 marks question. Okay. What the question says, you see, the size of the data count register of the DMA controller is 16 bits. Data count register they given 16 bits here. Processor need to transfer a file of 29,000, so 29,154 kilobytes from the disk to memory, main memory. The memory is what byte addressable memory. The minimum number of times DMA controller needs to get the control of the system bus from the processor to transfer the file from disk to memory is dash. Simple question, right? How simple, sir? See, this large file they are transferring not by the bulk transfer, bus mode. They are transferring what? Through block transfer mode. Where the givens are block transfer, they say data count register is 16 bit. Now they are asking how many times I have to inquire for the system bus from the CPU to transfer this large file from the disk to memory. They are asking how many times I have to inquire. So they did not say the cycle stealing mode. They are not transferring one by word. They are not transferring by word. They are transferring what? Some block wise. What is block size? Block size depends on, observe here, block size nothing but data count register. They said data count register is 16 bit. I said no, data count register 3 bit. So 8 words you can transfer. If the data count register is 16 bit now, so how much data you can transfer? How much data you can transfer? Number of bytes. Number of bytes can be transferred. Transferred. One time, transferred. So means once you get a system bus in one. So what I can say, in one request you can say. So number of bytes can be transferred in one request. One request from the processor. Once you get the system bus equal to 2 power of 16. So 2 power of 16 is equal to 64 kilobytes you can transfer. This meaning, you understand this line meaning. Once you get the system bus from the processor, once you initiate the starting byte by byte you have to transfer until what? Whenever data count register becomes 0. How much data you transfer? 64 KB you transfer, release the system bus, again inquire after one cycle, one instruction cycle. Once you get the system bus, again transfer the 64 KB file. Now question is that how many times I have to inquire? So now the question says that how many times you have to inquire? So number of times. Okay. So number of times. Okay. So DMA. Okay. DMA. So DMA request to the CPU for what? For system bus equal to one request you are transferring 64 KB file, right? What is the larger? What is the file you are transferring? 29,154 kilobytes you are transferring, right? So what one time how much you are transferring? How much time you can transfer? 164 KB, right? Once you get a system bus, I can transfer 64 KB, release system bus. Then again inquire. So number of times inquire can be done this large file by this one time. So KB cancel. So now you divide 29,000. You divide 29. So 29,154 divided by 64. So 455.5. So 455.5 something is there. Now tell me, so should I say 455 times you have to inquire, or to 456 times you have to inquire? Yes. Can you tell me, all of you, how many times I should inquire? 455, 456? Please understand, fully 455 required. In the last request, some 50% of the file will transfer. So definitely you would understand. Here. So number of times the system bus need to be inquired is 256. So 250. Sorry, 456. No, sorry, 456. 456 is the answer. This is a numerical type question. 456 is the correct answer for this question. I hope you understand the DMA part. Like those some almost 4 or 5 problems you solved in this one. So one more question. This is question number 6. Question number 6. You see the question number 6. So I hope you understand till this. Till this is clear, right? Look at another question. Another interesting question. It is old paper 2004 or 5 times they have framed this question, and nicely framed. We can understand now importance of the DMA or working principles of the interrupt driven controller. Understand? They said on a non-pipeline sequential processor, a program segment which is part of the interrupt service routine, is given to transfer 500 bytes from the IO device to memory. IO device to memory, you have to transfer how much data? 500 bytes. By using which methods are interrupt driven method? I said no, 3 protocols we have, 3 modes are there: programmed IO, interrupt driven IO, DMA. They said first non-pipeline processor, they are using interrupt driven. What is interrupt driven says that? Briefly I can tell you. So now devices having the provision to interrupt the processor, means saying that whenever any device is willing to transfer the data from device to memory, it has to interrupt the processor. Processor keep on checking every instruction cycle. So DMA vector, like interrupt vector, if any interrupts are there, it will initiate the IO transfer. Who is initiating? CPU will initiate the IO transfer from disk to memory. But in case of DMA, so CPU will not initiate the IO transfer. Who is initiate? DMA controller will initiate the IO operation. So that's a differentiation. So as part of the interrupt service routine has to run to transfer 500 bytes from device to memory. What the process? You have to initialize the address register. Address register means what? Where to transfer. Initialize the count. How much to count? 500 bytes. Load a byte from device. You would read the byte from device and store in memory location the address given by the address register. Store in memory address register. That process we have to observe. Increment the address register, next location. Decrement the count register, reduce how much data, leftover data need to be transferred. Now see, so now the last line is not visible, I am telling you, I am reading. If count not equal to 0, go to loop. Where is loop? Loop is here, okay. If the data count register, please count register 500, right? If count is not equal to 0, go to loop. If the count becomes 0, you stop. This is a program. Set of programs you need to execute it. Set of program need to execute to transfer the data from disk to memory. So I hope this is clear. Steps clear. Initialize the address, initialize the count, read a byte from memory, disk, and store whatever location specified. Increment the next location, decrement the count, continue the steps until the count becomes 0. Fine. So look next one. Assume that each statement in the program which you mentioned is equivalent to a machine instruction that takes 1 clock cycle to execute if it is a non-load store instruction. Understand the line. So this code is part of the interrupt service routine. This code is part of interrupt service routine. They are saying that the high level statement is equivalent to machine instruction. The non-load store instructions take 1 clock cycle. The load store instruction takes 2 clock cycle to execute, and the designer of the system also has alternate approach of using what? DMA. What is the alternate approach? It is a DMA controller to implement the same transfer. Instead of running this interrupt service routine to transfer the data, I can implement by DMA, alternate approach. Now DMA controller required 20 clock cycles for initialization, other overhead. We know initialization steps only I mentioned. Each DMA cycle, transfer cycle, one cycle of the DMA takes 2 clock cycles to transfer 1 byte of data from device to memory. Now the question is that what is approximate speed up of the DMA controller based design is used in place of the interrupt driven program based input output? Meaning what is approximate speed up we can achieve with the DMA controller over the interrupt driven IO. They said traditionally I use the DMA interrupt driven, so and so clocks will take, they said, and alternate I am using DMA. Now how DMA effectively working they are asking. So observe, first of all need to find out time in case of interrupt driven IO. So time nothing but in terms of clocks only, time nothing but in terms of clocks. Okay, what they said on points. So these are the instructions, equivalent to machine instructions only. They said very clearly, they said very clearly, so each instruction is equivalent to machine level instruction, they said, now each instruction equivalent to machine level instruction. If an instruction is non-load store, it takes 1 clock cycle. Can I say this taking 1 clock cycle, this also taking 1 clock cycle, and the load store instruction taking 2 clocks, load a byte taking 2 clock cycle. So this also take 2 clock cycle. So this take 1 clock cycle, this take 1 clock cycle, this take 1 clock cycle. Correct or not? This take 1 clock cycle. Now see how many times is this instruction loop part, from here to here. So first 2 instructions will execute 1 time only, but this loop will repeat how many times, 500 times or not. Now tell me number of clock cycle required for interrupt driven IO will be first plus 1, 1, right? Initialization. After that, load instruction takes 2, store instruction will take 2, and increment 1 clock, decrement 1 clock, and checking condition 1 clock, right? So now see this will repeat how many times? Is it not 500 times or not? Say yes or no? This will repeat 500 times or not? See, initialization. So what is initialization? Address register, count register. Loop will start. Load a byte, store a byte, increment address register, decrement data count register, check the condition. This loop will repeat how many 500 times or not? Yes or no? Now see, so 1 plus 2, this value will be how much? How much this value? 4, 5, 6, 7. 7 means what? How much? 3502, right? This is going to be 3502, right? 3502 only. So this is 4, 5, 6, 7. 7 into 5, 35. 3500 plus 2, 3502, right? Yes or no? Now time with what? DMA. What the DMA said? For initializing DMA taking 20 clocks. And after that 2 clock cycle for each byte. How many bytes you transfer? 500. This gives how much? So 1020. Now speed of factor. What is the meaning of speed of factor? The speed of factor means comparison. So non-interrupt driven IO 3502 divided by 1020. 3502 by 1020. Yes, what is the answer is giving? What the answer gives? 3502 divided by 1020. This gives 3.4. 3.4. Is there option? 3.4. Yes, option A is right. Option A is right answer for this question. So this way problems we can see on DMA controller ma. So now the 3 types of problems which we discussed, like the type 1 will be based on the cycle stealing mode, even burst mode. Sometimes they ask how many times required to inquire the system bus, or they can do the comparison between programmed IO, interrupt driven IO, interrupt driven to DMA controller also. Even there was a question you can attempt this framed in 2000 GATE 2023 paper. They do the comparison between programmed IO, interrupt driven IO. That you also observe, you can able to answer it now. Fine. So now like very next session I'll be coming up with another subject, that is operating system. So like so total session which I have taken for on computer organization, 16 sessions we have taken. So please, you can watch all those videos. Definitely you are going to be benefited, because most of the important topic from the COA I have covered. Then again, I'll be giving a schedule in the next session. I'll be discussing what are the topics I'm going to discuss from OS also. There also I'll try to cover the important topics, especially like process management and memory part I'll be discussing clearly. So that also definitely going to be beneficial for you. Thank you so much, all of you.